In this video, we will use three-dimensional graphing software to graph the given quadratic surfaces given by the implicit equations. We will be using the 3D Calc Plotter from the Exploring Multivariable Calculus site shown here, and there are two options. One option is the 3D Calc Plotter that requires Java, which will not work in all browsers. We will be using the second option, which is a 3D Calc Plotter JavaScript app, which works on most phones, tablets, as well as in most browsers. Let's open up the app and graph this ellipsoid. Once the app is opened, this is the default surface that is always graphed. Because we'll be entering implicit equations, let's go ahead and clear the graph in this window by checking this box here on the right. But we can also clear the graph by clicking this button here. So this will clear the graph, but to delete the window, we can click this small X. And then to the right of Add to Graph, we click on the arrow, which brings up this drop-down menu, and we select Implicit Surface. And here's where we enter the implicit equation. So we'll go ahead and clear this. The equation of the ellipsoid is x to the second divided by 16 plus y to the second divided by 4 plus z to the second divided by 9 equals 1. And now we can adjust the intervals for x and y here, as well as the scaling on the axes here. Let's go ahead and just graph it as is by checking the box on the left. Instead of adjusting the window, let's just zoom out by clicking on this minus here, and now we have a nice graph of the ellipsoid. We can also make the surface transparent by clicking on this magnifying glass here, which allows us to see through the ellipsoid. And now let's graph the cone. The equation of the cone is x to the second divided by 16 plus y to the second divided by 4, so let's leave that part. And then we have equals z to the second divided by 9. And now we can press Enter or click Graph. Here's a graph of the cone. Notice how it's not really that smooth. We can make this more smooth by changing the number of cubes per axis. Let's change this to 30. Press Enter, and now the cone is more smooth. More specifically, this is an elliptical cone. Next we have the cylinder, which is given by the equation x to the second divided by 16 plus y to the second divided by 4 equals 1. So we'll just delete this and enter equals 1 and click Graph or press Enter. And now we have the graph of the cylinder. More specifically, this is an elliptical cylinder. You can zoom in or zoom out using the plus or minus here. Now let's graph the hyperboloid of one sheet, which is given by the equation x squared divided by 16 plus y squared divided by 4. And then we have minus z to the second, or z squared, divided by 9 equals 1. And click Graph, and we have the hyperboloid of one sheet. Let's zoom out to get a slightly different view. Next is the hyperboloid of two sheets, given by the equation negative x squared divided by 16 minus y squared divided by 4 plus c squared divided by 9 equals 1. After making the changes, click Graph, and now we have the hyperboloid of two sheets. Next is the elliptical paraboloid, given by the equation x to the second divided by 16 plus y to the second divided by 4 equals z divided by 3. We now have the correct equation. Click Graph, and we have the elliptical paraboloid. Again, if we wanted to, we could adjust the axes manually down here at the bottom. And our last quadratic surface is the hyperbolic paraboloid. This is given by the equation x squared divided by 16 minus y squared divided by 4 equals z divided by 3. We've made the changes, click graph, and now we have the hyperbolic paraboloid. So we've reviewed the quadratic surfaces and also learned how to enter implicit equations in the 3D calc plotter. I hope you found this helpful.